Welcome to our lesson on traps and zaps, things that can go awry, so to speak, when you're doing statistics kinds of activities. So last time we saw, you might call them some traps. We were looking at sampling technique, and what we saw, of course, was that bad sampling technique can give you bad results. And what's so bad about the results? What's so bad about the sampling technique? Could you identify what the bad sampling technique does that messes you up? Well, it gives you a sample that's not representing or not representative of the population you're interested in. And by the way, population doesn't have to mean like everybody in the country. It could be that you're interested in, what kind of boat do fishermen like to use or something like that, and then your population would be fishermen that use boats, I suppose, right? So anyway, but there's a population of interest, and you want your sample to be representative of that. So you don't want to do things like self-selected, because you'll get people who probably are eager to share their opinion, which is not representative of the general mood and temper of the population, and so on. Self-selected was bad. Convenience sampling was bad. There were samples techniques that were bad. Well, we go beyond sampling technique in this lesson to look at other things that could go wrong, and I've got a collection of about 10 or 11 of them, and I hope you kind of enjoy this. And I'll just have an example for each one. So okay, here we go. Example 1. Children's Defense Fund. Now this, by the way, these are all true stories. These are true. I didn't make these up. The Children's Defense Fund reported 67% of students who were suspended from high school were suspended at least 3 times. What were they trying to say with that statistic? Well, it's the defense fund, right? So what they were trying to say is that, suspension, that's not a good thing, because really you're just suspending the same people over and over again, and you're, miring them in a life of whatever. Getting them off to a bad start's what you're doing. So there's their statistic. 67% of students who were suspended at least 3 times. Okay. Now, it might seem okay. They don't give you any real indication of what could be wrong here. But this is an example of something that is probably more common than it should be. Not that it should be common at all. This is a case of something called, and you want to be aware of this, dishonesty for a good cause. Human beings are good at justifying their behavior, no matter what kind of behavior it is. Dishonesty for a good cause. It's not that they're lying outright. Let's write this down. Not that they were lying outright. That would be bad. But what they're not telling you, they didn't tell you something. They didn't tell you it was a sample of 3. 3 students. 3. So that's how you come up with 67%. Looks like 2/3, doesn't it? So 2 out of those 3 students were suspended more than once, I guess. Not a big enough sample size. I hope you see that right away. Not a big enough sample size. If your population of interest is all students who have been suspended from high school, there's a lot more than 3 of them. There's got to be, right? That you should be sampling randomly, simple random samples from that population, not just finding 3. I don't even care how you find the 3. That sample size is too small. It's too small. But they ran with it anyway. And they ran with the story, I should say. And why did they run with it? Because they said, well, it's for a good cause. We're trying to do the right thing, so it doesn't really matter if the statistics are all, up to snuff and all that. We're trying to do something good here. So that happens a lot. It happens with, there was a breast cancer campaign a while ago where they stated some statistic that turned out to be wildly inaccurate, but they're like, no, it's for a good cause. Come on, man. We got to get people to whatever. So be aware of that. It's out there. It happens a lot. Dishonesty for a good cause. Now, the next one, I don't think I'll have anyone be surprised too much by this one. So the Dove Chocolate Company, example 2, they sponsored research into the benefits of eating dark chocolate every day. Every day, have some chocolate. And the research showed that people who consumed 4 Dove Darks per day over a period of 5 years, that's a pretty long study, they were in fact 10% less likely to die from a heart attack. So how do you like that? I remember that story being out, in fact. Dark chocolate is good for you. Dark chocolate every day is good for you. I remember hearing that story. But when you hear that it was sponsored by the Dove Chocolate Company, doesn't that make you wonder if there's something a little bit not quite right? This is called a conflict of interest. And we're all aware of conflicts of interest, I believe, right? This would be just like, let's say it's similar to big tobacco. You guys are probably too young to remember the big craze against big tobacco. But big tobacco telling you smoking is safe based on their studies. Well, it doesn't have to be that they're actually lying outright. Okay, same as example 1. Well, it almost counts as lying with sample size of 3, but they weren't outright lying, and they don't have to be outright lying. It might just be that they hired some researcher to say, hey, can you do a study for us, whether we're talking about the chocolate company or the tobacco company or whatever. Do some research of our product and tell us it's good for people or whatever. And, it might be that the person who's doing the survey, whatever, might be interested in doing another survey someday, and so they're hoping that maybe, if we throw out this data point and we throw out that data point and make it look good, we'll get another grant. Yay! So you got to be aware of conflict. Conflict of interest should always make you suspicious, which is why it's illegal in a lot of situations. You can't have a conflict of interest there. Go to jail or whatever, 2 down, we got more. Here's a good one. Cigarettes raise your pulse rate. Ooh. A study of 5,000 randomly selected smokers proves this, showing a strong correlation, 0.96, yep, that's a strong correlation, between the number of smokes per day and the pulse rate. Okay, so what they're saying is, I'm sort of imagining some kind of a graph somewhere in their data or whatever, where they put the number of cigarettes or something on this axis, and then they put the pulse rate on this axis, and they took a whole bunch of measurements and then they graphed it, and people that had this many cigarettes had this much of a pulse rate, and it's a 0.96, which means it's not a perfect straight line, but it would probably look pretty darn close to a good one if you just kind of put a line through the middle of it, right? And so you say, wow, man, more cigarettes, higher pulse. Yeah, that looks conclusive. But hang on a second here, but wait. What would happen if you graphed this? Let's say you put you're surveying cities or something. This is the number of churches per square mile or something like that, right? So when you get into the city where the streets are all close together and so on, you're going to see churches on almost every block. Go to Minneapolis sometime, you'll see that. And what you'll also see on almost every block is a bar. Number of bars per square mile. And I bet you anything, if you were to graph the number of churches per square mile versus the number of liquor establishments per square mile, it would look something like this. So, is this telling us that people that go to church are driven to drink? Is that what that's telling us? That's not really telling us. There's something else going on behind the scenes, right? There's actually a third factor. Sometimes they call it a lurking variable or something like that. But anyway, there's a third factor. It's simply population density. Where you have a large population, you're going to have a large number of services for that population. Church is one kind of service, bars are another kind of service. So it's just population density is the factor here. Or this one's a good one. Let me do another one. Let's say you put the number of steaks that you eat per week, number of steaks consumed on this axis, and you put your income on this axis, income in dollars on this axis. Wouldn't you know it? You graph the data and you find that basically people with money eat more steaks, and so you've got this correlation here. So does that mean if I eat more steak I'll get rich? That's not what it means, right? So hopefully you can see the illogic going on here, and this has a nice little way of it's a nice phrase, catchphrase that goes like this: correlation does not imply causation. Just because two things happen together doesn't mean that one is causing the other. Okay, there could be something else going on that's linked to both of them, right? So anyway, be aware of that, because this happens all the time. People say, look at that. Wow, one is causing the other. And it's like, no, it's not. Or at least not necessarily. It could be, I suppose. Okay, here's another example. Number 4, people who followed the Atkins diet for a year, they showed significant weight loss. Hey, if you've been watching these lectures like you should, that should ring a bell. I hope that rings a bell. People who followed the Atkins diet for a year showed significant weight loss. What's the problem with this? They don't have to be lying, but they could be sort of, well, is it equivocating? I don't think so. It's just not coming out with the full story is what it is. The full story is that statistical significance is one thing, but it does not necessarily imply practical significance, or just it doesn't imply that it was a large result. They lost weight. Wow, this is statistically significant. What does statistically significant mean? It means not due to dumb, or I can't even say that. Not likely due to dumb luck. In other words, they lost some weight. But if you remember, it was like they followed a whole bunch of people around for a year, a whole bunch of Americans, and they found out, wow, they lost an average of 4 pounds that year. Now, that's not what you would expect by chance. If you randomly grabbed a whole bunch of Americans and followed them for a year, you might expect their weight would stay about the same, or maybe even go up a half pound or something like that. But it was only 4 pounds. And so it's like, okay, you're going to go on a diet for a year. You're going to commit yourself to this strict diet for a whole year for the sake of losing 4 pounds. Is that really worth it? It ain't worth it to me. I like my strawberry shortcake and my chocolate fraps and all that kind of stuff. I like it. I'm not going to do it. I wonder if those are legal on the diet. Anyway, whatever. Okay, 4 down. Here's another good one. Number 5, Biff polls 485 young women at the mall. Ask them how much they weighed. And his data showed an average of 111 pounds. Well, this is a little bit like convenience sampling. You're going to the mall to ask 485 young women. But, let's leave that aside. He's asking, hey, how much do you weigh? And his data shows that they weigh, on average, 111 pounds, which sounds on the light side to me, but whatever. I suppose it depends how old they are. It does say young. But anyway, what could be wrong here? Well, there's a principle you want to use. You want to follow this as much as possible. And the principle is measure, don't just ask. It would have been better, this study would have been better if he had these young women hop on the scale, because then he'd know how much they weigh. If you're just asking them, well, first of all, do they know? So they might be taking a guess. They're probably rounding down. Anyway, so if they weigh 112, they'll probably say 110, right? Or even if they're guessing, they'll probably round down. So they're probably rounding down, which means maybe they don't really weigh that much. Maybe it's a little bit more than that. Or they're probably rounding down a lot, because a lot of girls, at least if you go back a few years, they were always like, oh, they wanted to be skinny. I don't know if that's quite the same anymore. Seems to be changing, but they were always like, oh, I don't weigh much. I really don't. I don't. So measure, don't ask. If you want accurate results, measure, don't ask. Number 6, I think we got 11 of these, so we're getting like halfway. What's going on here? We got a teachers union, and they called all 250 members, or put a survey in their mailbox or whatever. All 250 members of a teachers union. Actually, they were telephoned. It says right there. And they were asked, hey, how are you going to vote in the next election? And 160 agreed to respond. Right now you're thinking self-selected, I hope, and you're saying, well, that's not a real good sampling technique. It would be better to corner them in the hallway and get their answer. But even then, how do you know they're telling the truth? Anyway, a full 98% identified as strong Democrats. Okay, that is a high statistic, right? That is a high statistic. And I think I kind of gave the problem away when I said corner them and force them to tell you, but they might lie. What's the problem here? Okay, it is only 160 agreed to respond. Now, the technical name for this would be a non-response bias. there's a whole bunch of people that are staying silent on this one. You're asking them and they're like, nope, I'm not going to say nothing. Not going to say nothing. And I'm going to say it's similar to self-selected, because they are kind of selecting themselves they're opting out. So that's kind of a self-selection, right? So you're not going to get a representative sample. Not a representative sample. Not necessarily. You can't guarantee anything's wrong, but you can't guarantee anything's right either. So it's not a good idea, non-response science. And I'll just ask you this question so you can see why this is bad. How many members of a teachers union will be willing, or will be ready? Let's put it that way. They'll be ready. They'll be ready to announce that they are closet Trumpers, right? Huh? Now, Trump got elected somehow one time, and that's because a lot of people voted for him somehow, and the polls kept saying, nobody wants to vote for this guy, and that's because the way they were answering the polls, they said, no, of course not. I'm not one of those people. I'm not one of those people. So if you're in a teachers union and you really are a closet Trumper, are you going to tell your fellow union members? I really don't think so. Might be one thing to say Republican, but it'd be another thing. Even that's no good these days, right? But anyway, to say you're a Trumper, no way. It's not going to happen. So you're not going to respond. And you're going to get a non-response bias. Not a good way to sample, not trustworthy results is what I would say. Here's another real story. ABC's Nightline. I don't even know if that's on anymore, but was a TV show. Nightline, they asked viewers to phone in. They must have done some story on the UN and whether it should move out of New York City. And they're saying, hey, phone in, give us your opinion. And they got a pretty good sized sample here. Look at this, 186,000 people called into their show. Must have been a nationwide show. And a full 67%, that's like 2/3, said, move the UN out of New York. We don't like it here. They're bad people or whatever. Okay. Now, what's the problem here? Well, are you recognizing a self-selected sample? You know who's calling in? The UN haters. The ones that have a grudge, or whatever you want to call it. Grudge. I don't know if it's grudge, but they have a bone to pick. What would you say? They don't want the UN there. That's what they say. They really don't want the UN there. That's what I would say. So for comparison, a scientific poll, which means simple random sample, and you're being careful and all that other stuff. A scientific poll of 500. So if you do a scientific poll, one of the advantages is that you don't need to have such a large sample. Compare this sample, 500 versus 186,000. Holy cow. You might think, oh, 186,000, it's got to be accurate, but that ain't necessarily so, not if it's a self-selected sample. A scientific poll, a nice, simple, random sample of whoever, of 500 people, found, give me a pen, found 72% said do not move it, which means it couldn't have been more than 28% that said move it, right? Compare that to 67 versus 28. Boy, is that a difference. So that can really show you the powerful skew you can get by accepting a self-selected sample. So whenever there's a website that says, hey, call in a website that says, hey, email or whatever, respond to this survey here, tell us what's going on. It's like, that's not really worth much. What you're sampling is not, for one thing, if it's ideal, you're just sampling the people who know of that website. But even so, it's going to be the ones with the stronger opinions who know about that website. So you're not getting real general information about the public out there. Here's a good one. AOLs. Anyone have any idea what that means? America Online. It was one of the first internet providers. Anyway, they posted this question on their website. Have you ever been hit by a computer virus? And it garnered 170,000 responses. So again, we got the self-selected sample. That's not so good. But this is something worse than that. The results below seem to show that 3 people, or I would even argue, looking at that thing, maybe 3 or 4 people have been hit. These are the people that got hit by a virus. About 3 or 4 people got hit for everyone that didn't. I mean, look at the size of the bars there, right? It looks huge, right? 1, 2, 3. Yeah, that's more than 3 times. That's like three and a half times or something, right? But what we have here is kind of akin to reading the fine print. If you look at this number, if you try to squint and read that number is 109,000. This number is about 63,000, something like that. And so from here to here, 63 to 90 to 109, that would be a factor of 1.7. Just take the 109, divide by 63, you get 1.7. So it's a factor of 1.7, not 3 or 4. So the scale is misleading, right? You really should start the scale at 0. By starting the scale at 50,000, it's kind of saying, okay, if 50,000 means nothing, then these guys are like a 13,000 more than nothing. And these guys are like a 49,000 more than nothing. And so the 49 versus the 13 exaggerates the difference quite a bit. You should start your scales at 0. It's a misleading graph. Misleading graph, just because of the way you graphed it. Okay, we're moving now, folks. We're on example 9, page 3. I like this one of my favorites. I'll give you a second to read that one yourself. That's about how long it takes me to read it. Okay, so in a random sample, 1,400 American voters, 84% say the president should bypass Congress with executive orders. Wow, that's saying something. Bypass Congress. Oof. And by the way, this was in the news. I am not making this up. This was a thing if you go back a decade or so. Who were they? I think that was Obama. They were trying to get Obama to do that or whatever. Anyway, it doesn't matter. But the fine print was, and actually I did make the question up. This question I made up. You know what? I probably made the whole thing up now that I think about it. I tried not to make them up, but this one I think I did. So in a random sample of 1,400 American voters, okay, whatever. But the question was this. If it would finally fix our chaotic healthcare system, no, I did not completely make this up, in a way that's eminently fair, it makes everybody in the whole country happy, and this part I did make up, and stands as a model of inspiration for other countries, don't you think the president should bypass Congress just this one time in history in order to get this done? That's called a push poll. Push polls are, again, more common than they should be. So what you're doing is you're trying to skew the results by the wording of the question. You're trying to get as many people as possible to say, of course he should. Yeah, he should do it. Yeah. It's going to be the one time in history that he does it. Okay. It's going to be a model of inspiration. The whole country is going to be happy, and it's all going to be fair, and it's going to fix all this chaos. Yeah, let's do it. Trying to skew the results by the wording of the question. Okay, so beware the push polls. If anybody asks you a push poll, you might, I don't know what you might do. You might want to just answer the way they don't want you to answer, just to try to make it more fair or something, make the results more fair. I don't know. Not that that would work, but okay. Another one, 10. In a well-conducted survey, this is real. I did not make this up. In a well-conducted survey, 1,450 American adults were asked, does industry contribute more or less to air pollution than traffic? So which is worse, industry or automobile traffic? A full 57% responded it's industry. Industry is more to blame than traffic. Okay. Full disclosure, so to speak. Full disclosure, it was 57% that said industry, and it was 24% that said, nah, it's traffic, and then there was 19% that said they were unsure. They're like, I don't know, whatever. Okay, cool. But, in fact, let's do a different color here. But, when they swapped the places of the the two words. In other words, when they ask the question this way, whether air pollution contributed more or less, or not air pollution, whether traffic contributed more or less to air pollution than industry, when all they did was switch the two words around, they got these results. Only 45% said industry. 27% said traffic. So traffic went up, industry went down. And by the way, the unsure went up as well. 28% were unsure. Whoa. Why the different response? It was, logically speaking, it's the same question. Just from a pure logical premise type of point of view or whatever, it's the same question. But that's not the way human beings work, of course. This is something well known about called the anchoring effect. And it's basically the brain latches on to what it sees first or hears first or whatever. The brain latches on to whichever comes first. So when the question was, is it industry? More people are going to say industry. When the question was, is it traffic? They mentioned that first. More people are going to say traffic. More people than did before is what I mean. It didn't skew the... It's still industry that's worse than traffic, but you can see the numbers are significantly different here. So the brain latches on to whichever comes first. And this is why you go into any store, anyway, any internet, anywhere, and the price tag says $49.95, not $50. You will never see a price tag that says $50 unless maybe you're at a yard sale or something. But if you're on the internet buying stuff, $49.95. And why is that? It's because they know you're going to get anchored on the 4. You're going to see the 4 first, and you're going to be ready to part with 40. You're going to be more ready to part with 40 than you would have been to part with 50. So even though it's $49.95, which really is very, very close to 50, still the brain's going to anchor on the 4. It's what it's going to do. They actually had another, this is kind of interesting, they had another survey where they were trying to get people to estimate like eBay items, like how much would you pay for this eBay item. They took the price down and they just said, what would you be willing to pay? But first, write down the middle 2 numbers of your Social Security number. And sure enough, people who had high middle 2 numbers would bid higher amounts. And the people who had low 2 middle numbers would bid lower amounts. And you can't say that your Social Security number causes you to bid more or less. It's just another example of the anchoring effect. The mind was anchored on a lower number, so it gave lower numbers out. Or it was anchored on a higher number, so it spit out higher numbers. Whatever, anchoring effect. Watch out for that one. Boy, that one's a real nice one to be aware of just in your general life, I think. Hey, what's going on here? Go there. Go. What did you do? What did you do? What is going on? Open. Yeesh. That's the problem with having tap screens. All right, so before I do the last example, I think I want to point something out here. I guess I'll kind of sneak it over to the side here. Remember earlier that we were saying statistics can't be used to prove anything? And we were saying that because we said it's all about probabilities. It's all about random fluctuations. So, you never know which way the ball is gonna bounce, so to speak. Well, hopefully you're starting to be aware that the human component, because it's chance, let's put it this way, because it's all chance. Nothing is ever guaranteed. The human component makes it much worse. When you involve the human in the fudging of the statistics, so to speak, things get much worse. And it's not on purpose. It's because we have things like the anchoring effect that we have to deal with. You might have someone who's doing a push-pull on you. That's no good. We might just, present the data in a misleading way or whatever. It might be a self-selected sample. You have to be aware of all these traps. Okay, the human element is the thing you want to get rid of as much as possible. So here's the last thing I'm going to mention. I've actually seen these at the App Store. Some kind of win the lottery app. pretty sure it was the App Store where I saw this, enables you to analyze the past results of your favorite Powerball lottery. You can choose from strategies. You can bet on numbers that haven't come up. They're due, right? You can bet on hot numbers. They keep coming up. They're going to happen again. You can bet on numbers that have been coming up more or less on schedule, and it's on schedule, and it's going to happen again on schedule, and let's bet for that, and whatever. Okay, why shouldn't you bother? The problem is it's completely random. And by the way, there's some mathematicians out there somewhere who have proved that the stock market is also completely random. So you'll see people on YouTube trying to make predictions based on the Dow has done this and this and this, so obviously it's going to do this next any day now. You can't say that. It's random. It's completely random. You certainly can't say it about the lottery. That's better. It's completely random. No betting strategy can help. If it works today, it won't work tomorrow. And how can you say that it worked today? Because it didn't work tomorrow. It didn't work for the next 18 weeks. How can you say that it really did work that time? It was just a chance result, right? No betting strategy will work with random stuff, with random outcomes. If it's random, you can't predict a dang thing. That's what random means. It's completely free to do whatever it wants to do. But, and this is what I wanted to get at, the human brain, it turns out, is really good, you might say it's wired this way, is really good at seeing patterns, which is valuable, right? You're in the woods and you're looking out for the jaguar or whatever. How big is a jaguar? Do you have to worry about a jaguar? Probably. You're in the woods. You have to worry about where's the jaguar? Where's the hungry jaguar? I don't want to be near that thing. You have to look at all the leaves and stuff and try to pick out where's the jaguar. You have to recognize the pattern, right? So the human brain is really good at seeing patterns even where none exist. And that's the problem with the guy that gets all excited and writes a lottery app. He thinks he does see patterns, but he doesn't. There's no patterns. You might think you see patterns in the stock market, but there aren't. You're not seeing any patterns. The human brain is really good at seeing patterns even where none exist. And it's also bad at recognizing randomness, which means it should be able to say, hey, that looks random to me, but it doesn't. It doesn't look random because they're saying, hey, look, there's a pattern. There's a pattern. That number is, it's going to come up. It's going to come up. And then it does. Oh, I told you. I so told you. So you got to be careful because your brain's going to get excited on you. Humans they're not really good random number generators. So if I said, hey, make up 3 random numbers between 1 and 20, most likely you're going to make up 3 numbers that are kind of spread out evenly between 1 and 20. But it could, if you ask a random number generator to do it, you may very well get 2, 2, and 8, which doesn't look like it's spread out enough, right? So anyway, don't trust your own brain to tell you whether something's random or not, or whether something has a pattern or not. Careful of all this stuff. Careful of all this stuff. Okay, I hope you found that as kind of a fun lecture. I like it. I have fun with this stuff.